All right, so this is our last new lesson for this particular semester. We're going to look at area of some of our common shapes. I will give you one more lesson that kind of reviews our perimeter area volume with a couple extra questions that use some algebra. Just to give you a little extra before we do our final exam. I know many of you, you'll probably be fine without that review now that you've got your memory jogged, but just a review video can be really helpful. And then we'll have a mandatory review before the final exam, which you'll submit, and then we're finished for Christmas break. So it's coming up very quickly. Now, before I start, I'm going to see if I can adjust. Oh, we're good. Just making sure my sound was good. If for some reason you're having difficulty hearing me, please let me know. I've had a little bit of trouble in the past with a couple videos seeming to have really weak audio. I'm going to see if I can resolve that if that happens to be a concern to you. All right, so in this lesson, we're going to look at the area of triangles, squares, rectangles, and circles. We're not going to cover volume in this particular section. So what is area? So first of all, area is the measure of a 2D space. So the perimeter is the black line around the outside of the white triangle. The white rectangle, the white inside is the area. I can't do that quite so nicely with our triangle, but along the outside we have our perimeter, the space inside is our area. So area is always two-dimensional. Because it's two-dimensional, you'll always be multiplying two dimensions together, or you might tell radius times radius. That's two dimensions that get multiplied together. And when you do, two things multiplied together is the same as squaring them, which is where the unit centimeters squared comes from. So if we looked at a rectangle, let's say we have a rectangle and the area is 2 meters by 4 meters. 2 times 4, you multiply your numbers together, which would give us 8, and these meters times meters gives me my meters squared. So this would be our area. Area will always have the squared for units. You may see it written a couple of different ways. Sometimes I'll do square inches like words or actually write it out. You will never see square inches. You'll never see 12 inches squared like that. We do not use the symbols for squared when we do areas. So just one of those little things. The other thing to keep in mind is area will always be just feet, just inches. It will never be combined feet and inches. You may use combined feet and inches and convert it to a unit to calculate area, but your final area, you will never, ever, ever see feet squared, inches squared. You're just not going to see those, okay? So that gives you a little overview of a couple important things for calculation. So first of all, let's calculate. Now, to start with our area calculations, we're going to calculate the area of several squares to develop area conversions. So in this question, it says, what is the area of a square that is 1 yard by 1 yard in square feet? So the first thing I would do in a question like this, I want square feet for my answer. A square is just a type of a rectangle, so we know the formula for area is going to be length times width. Now 1 yard is equal to 3 feet. So we can put that into our diagram. I'm going to actually draw it out because I think sometimes that's helpful. Now I struggle at making lines straight on this thing. All right, so you have 3 feet, which is the same as 1 yard, by 3 feet, which is the same as 1 yard. The area is 3 by 3, which we could count, and we get 9 square feet. Okay, so if we think about a conversion, if the same square was 1 yard by 1 yard, this would be equal to 1 yard squared. This square is the same as 1 square yard. So you will notice that 1 square yard equals 9 square feet. Okay, 1 square yard equals 9 square feet. Now think back to your original conversions. Usually we say, well, 1 yard equals 3 feet. When we square it, we take the number that's in front of the feet and we square that, so we multiply it by itself. So this is how we make a conversion. Those are our new conversions that we use. I have a couple of questions that use these, and that will help us because sometimes it's really inconvenient to change all of your units at the beginning, especially if there's multiple units. The next one says, how many square inches are in a square that's 1 foot by 1 foot? Well, let's start out with our square. So there's our 1 foot by 1 foot. So that's 1 square foot, 1 times 1, okay? So this is our shape here. Now let's turn it into inches. Well, 1 foot is 12 inches, another 12 inches. We have 12 times 12, so 12 inches by 12 inches equals 144 inches squared. So from this, we have a new conversion again. We now know, using the same numbers that we had on our old formula sheet, that 1 foot square is equal to 144 inches squared. Okay, so it's pretty easy. Really, all we're doing, this number comes from our conversion chart, which is 12 squared. Let's look at one more. What is the area of a square that is 1 meter by 1 meter in centimeters squared? So we have 1 meter, which is 100 centimeters, another meter, which is 100 centimeters, just converting them. So 1 meter squared is equal to 100 centimeters times 100 centimeters. Our length times our width, which is equal to 1 and 4 zeros, so 10,000 centimeters squared. So this is just how we make a conversion. By doing those conversions, we actually practiced our rectangle formula. So hopefully that kind of makes sense for you. That's one of the pieces that I will definitely do a review on. And I've got my fingers crossed that you guys will get this a little easier than sometimes other classes do, just because it actually relates really well to carpentry. Oftentimes you'll know the dimensions of a room in square feet, but maybe you need to calculate flooring quantity in square yards. It doesn't always make sense to recalculate the area of the room. If you know it's 1,200 square feet, you should be able to just make yourself a conversion and use your new conversion. All right, so let's start with this one. We're going to use 2 methods just to get us to do some practice. So we'll divide our screen. How many square feet of shop floor space does a rectangular pallet take that measures 60 inches long by 48 inches wide? So we're looking at how much space something takes. That means what area does it take? So method 1. I'm going to call method 1 is the convert first. If you're somebody that struggles with understanding how to make those squared conversions, convert first. Converting first is often easiest because you don't have to remember that there's different conversions if something is squared. So when you convert first, we take 60 inches and we say, well, how many feet is that equal to? Well, 60 divided by 12 would be 5 feet. 48 inches. 48 inches, you should know, both of these ones you should know without really pulling your calculator, right? 48 inches is 4 feet. So the area is equal to our length of 5 times the width of 4. We're putting feet in, so we're going to get feet out. 5 times 4 is 20 square feet. You'll notice I'm switching back and forth between the different ways you can see it written. All right, method 2. We're going to convert last. Okay, when we convert last, what do? Well, first of all, we calculate the area. Area is 60 by 48, which is 2880 inches squared. Inches went in, inches squared is what we get out. But that's not what we wanted. We want to know how many square feet. So what we do is we say, well, Okay, how much is 1 square foot? So 1 foot is equal to 12 inches. So to make it squared, 1 squared is 1. We square our feet. We're going to square both sides of the equation. 12 squared, an inch is squared. So 1 foot squared equals 144 inches squared. Now you could draw the square out if you want to show. If you have a hard time thinking about it, think, well, 1 square foot is 12 by 12, which is 144 inches squared. You can write it out like that. Sometimes that can really help you out. Okay, so now we can convert. So we know how many square inches. I'm going from 144 to 12. So that means I'm going to need to divide. So area is equal to 2880 divided by 144 gives us 20 feet squared. Same answer both ways, doesn't matter which one you do. This little piece can be a little bit tricky, but I do want you to practice it. Next question. Determine the area of the following shape in square feet given the following measurements. So in the shape, this particular one, I said it's a rectangle question. Hopefully you can see where you would get rectangles from it. So with this question, there's a couple ways we can break it up. We need to make it into shapes that we know. So break it down into simple shapes. I decided, well, let's just divide this straight down. You could have, if you wanted to, you could have divided across. Either one will work. So I need to know, I know all the dimensions for this rectangle. So I'm going to call this rectangle area 1. It's 20 times 60. It's 120 square feet. I'll call this one area 2. Area 2 is not 60 times 30 because this rectangle is not 60 long anymore. So what we need to do is we need to find out, well, what's the length of this side? 60, take away 20, gives me 40. So this one's going to be 40 times 30, which equals 120 square feet. Total, just add them together. 120 plus 120 gives me 240. So we're just breaking them into simple shapes. You'll get lots of practice doing simple shapes in your next semester. This is something that's really common for you to need to know. Next semester, we're going to look at calculating the amount of concrete you need to pour a foundation. You need to know how to calculate areas, especially areas of shapes that look like this. Usually they're combinations of rectangles, but it's really, really important. Being able to calculate quantities for pouring concrete is something that's commonly a carpenter piece to know. So knowing how to calculate areas or even amounts of plywood, cover areas, there's a lot of situations where you'll need to know how to calculate areas of shapes that are simple shapes, but they're squished together or they're added together. All right, let's look at triangles. Triangles, gable ends are great examples of triangles. I don't have any practical examples in this particular question, but I know there's a couple of really good questions in the quiz. So determine the area of the triangles. I've given you 2 questions. We're going to leave them in the units that the question has them in. So this is in centimeters, so we're going to find it in square centimeters. This one's in meters, so we'll find it in square meters. So for triangles, the formula for the area of a triangle is base times height divided by 2. Where that comes from is triangles can be put together to make a square or a rectangle. I'm having a hard time drawing straight lines, sorry. And you'll notice if we take a rectangle and we put a diagonal line through it, we get 2 triangles, which is why it's base times height divided by 2. So that's where your triangle formula comes from. The height is always measured at 90 degrees to the base. So here's my base. The height is there, and we don't even care about these 2 measurements. We would worry about them if it was perimeter, but for area, we don't need the 2 of them at all. So in order to calculate, area is going to be equal to 29.8 times 17.8, which gives us an area of, divided by 2. Write down a little lower, leave my spacing, 565 and 22 hundredths centimeters squared. So there's our area. Pretty easy calculation. Multiply the top and then divide by 2. Over here, now when we do trig, you're going to see lots more of these questions show up. So our base is our 6 centimeters. The height is straight up from the base. So what we do is we kind of extrapolate our line out, and we've got 8 meters here, so that's our height. We don't care about the other two. They're not at 90 degrees to the base. So the area is going to be 8 by 6 divided by 2, which is 48 over 2, which is 24 meters squared. Just substitute in and calculate. Triangles are pretty common ones. Your triangles typically are more like this kind of triangle, which is like your gable end. All right, trapezoids. First couple years, I said, why do they need to know trapezoids? Where do you see trapezoids? And then I bought a house, and a section of our roof is a trapezoid. And I went, oh yeah, there's actually lots of examples of trapezoids in carpentry. It's not just one of those random shapes they give you. For my house, I have 2 roofs. So over the garage, there's a roof like that, and then there's a porch, and then it connects to the rest of the house. And this section of roof, you have a straight section that connects to the house, and then a diagonal that connects to the garage roof. This section here would be a trapezoid. So eventually, probably within 10 years, we're going to have to put a new roof on. When they figure out their areas, they're going to need to figure out a trapezoid. This particular trapezoid has angles on both sides. Sometimes you'll see that. Sometimes you'll see trapezoids that look like this. They don't have to have the same angle. Sometimes you'll see one really steep and one not so steep, but both at an angle. And then you'll see examples like these where both are the same length on each side. So those are some of our trapezoid information. So we want to find the area of the trapezoid in centimeters squared and in inches squared. So let's figure it out in centimeters squared first. The formula for a trapezoid is area equals big base plus little base divided by 2 times height. So this is our big base, and this is our little base, and this is our height. We don't even care about the 2 sides. Plugging it into our formula. So area is big base plus little base divided by 2 times the height. So what we're doing is we're finding the average of the top and the bottom. Area is equal to 20 plus 10 over 2 times 8, which is 15 times 8, which is a grand total of 120 centimeters squared. We just got 3/4 of the marks for our question. So we've got our centimeters squared, but the question asked for inches squared as well. So we're going to do the inch squared here. Well, there's lots of centimeters in an inch. So the conversion for inches and centimeters is 1 inch equals 2.54 centimeters squared. I don't want the squared, centimeters. Let's get rid of the squared. 1 inch is 2.54 centimeters. If I want to know area, I need to take the whole thing and square them. Thinking about that square that we drew. So we get 1 inch squared is equal to, we take our 2.54 times 2.54, which gives us, I didn't write down the middle number, 6.45. There's our new conversion. We are going from centimeters to inches, so it's going to be division. 120 divided by 6.45 equals 18.6 inches squared. So that's our other unit. Okay. Section those two off a little bit. So we're just making up that area conversion. So I've got that in there a few times, and hopefully it's starting to click and make sense for you. Always Always, always, always show me all of your work for questions like this, because if you make just a simple conversion error, you're not going to lose all your points for your question. A question that's worth 2 points, you might lose half a point for a conversion error, but you'll get all of your points for correctly calculating the right area using the other unit. Okay. All right, circles. What is the area of a circular patio that has a diameter of 9 feet 6 inches? Answer in square feet rounded to the nearest tenth. So circles, remember, had specific language. So we have our circular patio. The diameter is all the way across is 9 feet 6 inches, or 9.5 feet. Now, the reason I've immediately converted to a decimal here is because when we multiply by pi, or when we multiply, anytime we do areas, our answer will never be combined feet and inches. It's going to be all feet or all inches. So it's really good at the beginning just to convert. If you see feet and inches in an area question, switch it all to the end unit. So in this case, I wanted square feet. So I said, okay, let's take our 6 inches and turn that into decimal feet, and that'll make it easier for us. All right. So the formula for the area of a circle, area is equal to pi, which is 3.1416, r squared. So this is our diameter. So the radius is equal to 9.5 divided by 2, which is 4.75 feet. Now we can put that into our equation. 3.1416 times 4.75 feet squared. You'll notice the area is in squared units. It's the one that uses the squared radius. Little memory trick for days when you don't have your formula chart. Multiplying those two together, you get 70.88 square feet, or 70.9 square feet. Big key, always convert to one unit. No combined feet and inches. Okay? No combined feet and inches. Now let's look at our next question. We got just a couple more questions and then we're finished. The area of a circle is 12 meters squared. What's the radius and the diameter of the circle round to the nearest hundredth? So in this case, we have a circle. We know that the filled in area is 12 meters squared. We want to know what is the diameter and what is the radius. It's two things. So first of all, let's find our formula. So area equals pi r squared. Okay, since we have that, we have pi r squared equals 12 meters squared. Now we're doing some algebra. Instead of pi, let's put a number in. I know you could just leave pi, but sometimes it can make it easier for people to see. So I'm going to take out the meters squared just because I find sometimes extra letters can make it confusing for people. So we're putting meters into our equation, so we're going to get meters out of our equation. So keep that in mind. So 12 is equal to 3.1416, and I usually will keep it in brackets, r squared. That's just so I know all those numbers belong together. 3.1416 times r squared. Undoing that is division. Cancel out. R squared is equal to 3.81. Now what we need to do, we need to get rid of the squared. So just like in our algebra section, we take a square root. And when we take the square root, we get 1.95, and that's going to be meters because we put meters in. We're going to get, if we put square meters in, we're going to get meters out for our measurement. So we get meters out at the end, and a radius is a length, so it's not going to have the squared. Is our radius. Diameter equals 2 times the radius, which is 1.95, which is 3.90 meters. So there's our two pieces of information. Oh, just a backwards example. And the very last one, I figured let's throw in a combined shape. I believe this is also in your worksheets. So when you see this one in your worksheet, you'll already have the answer for it. You won't even have to think about how to do it. We want to know the shaded area. It doesn't look so shaded here, but the area inside this figure. Okay, what's the entire area? So in order to do this one, we have to recognize our shapes. So area 1 is a rectangle, area 2 is a triangle. So area 1 is a rectangle. It has a length of 13.4 times a width of 12.5. Putting those two numbers together, we get 167.5 meters squared. Meters in, meters squared is what gets out. Area 2 is our triangle. It has a base of 10 and its height is the same as the 12.5. So 10 times 12.5 divided by 2 gives us 62.5 meters squared. The total, 167.5 plus 62.5 adds up to 230 meters squared. So nice and simple. Just break it down and look at each piece separate rather than all kinds of little bits. Just a couple of tips. Before you calculate, make sure you're using a single unit. Now, this second reminder, I've left it here because it can often help people. Convert before you calculate. If you convert before you calculate, you don't have to do anything special. If you were in automotive, I would tell you always convert before you calculate because they don't do as many area calculations as you do. You guys should know both. And if something looks complex, break it down into simple shapes. Sometimes a question looks complicated, but everything breaks down into just simple shapes. So keep that in mind as you calculate, and that should give you enough in order to be able to do your quick quiz. We'll look at a couple more examples in our next lesson.